Hey everyone, and welcome to another episode of CNC Basecamp. Today I want to talk to you a little bit about how we can use geometric patterns in our woodworking for some really special effects. Now you can find geometric patterns about anywhere around your home. You'll find them on bedspreads, you'll find them in carpeting, shower curtains, you'll find them in all sorts of different areas. If you need a good source to find some geometric patterns, just go to the web. So let's take a look. This episode is sponsored by Inventables. Design it, build it, sell it. Learn more at inventables.com. So here I've brought up geometric patterns on Bing, and if we start to scroll through, you can find there's pretty much an endless number of interesting patterns. Now some of these are going to be a little bit extreme for woodworking, but there's so many that would just be really wonderful. Wonderful to use on the lid of a small jewelry box, a wall cabinet. I think some of these would make great running moldings for a mirror or a picture frame. Think of banding for a table or a small tabletop. It's really fun, and with the various softwares that we have in your CNC machine, it's not hard to do. So I want to show you two methods today. One in which we're going to take out a certain amount of material and then add some unique and pretty wood, and another that's purely reductive. So let's start out by taking a look at our first sample project, and this is a small wall cabinet. Now don't be too shocked by the colors. I'm creating essentially a stained glass effect on the door, and I'm using bright colors because it helps me separate the different parts out for setting up our cuts. So this is a very simple wall cabinet. It's about 24 inches tall, about 6 inches deep, and it's going to make a good simple project for us to work with our two types of geometric patterning. We have a door. I'm going to have European hinges in here and a couple of shelves. So very simple to do. The door itself began with a pattern that I downloaded as a PNG file from the internet. Let's go ahead and take a look at the actual panel of the door, and I'm going to show you how I started out. I'm in sketch mode now, and this is the very first step that I use to create a part in Autodesk Inventor. What you'll see there in the background is an image that I downloaded and brought into the sketch plane. I then began to draw lines on top of that, delineating each of the different triangle shapes. And I'm keeping an even distance between them, the 3/16. That's going to create essentially a stained glass pattern. And I like having that delineation between the various parts because I'm going to use a neutral wood, birch, and that's really going to help set off the more figured and colored woods like Purple Heart, Babinga, and Padauk. For those woods to really shine, they need to have a neutral color nearby. Otherwise, they all compete with each other. So this really shows off exotic woods. So if you have a box of scraps of different woods you've been wanting to use, this is a great application. Once I created that overall pattern, I then created a solid part, and I went in and picked out those individual areas, those individual triangular shapes, and I added color to them. So within the Inventor program, I'm choosing which species of wood goes where. Now, of course, I'm using some pretty garish colors in there, like the pink, but that's just helping me see and visualize where the different wood is going to go. With those colors as an aid, I'm also able to create DXF files specifically for the chosen woods. So as an example, let's take the orange color here. I created a DXF file which captured those shapes alone and not the others. I was then able to go into my program to create files, in this case Vectric, bring in that DXF file which has all the different shapes, and then I'm Then I'm able to take the individual shapes and move them onto my board that I'm going to cut with the CNC machine. So it's a fairly straightforward process. We capture an image of a pattern that we like. We bring that into our design program. We create the necessary patterns and shapes, save it as a DXF file, bring the DXF files into, in this case, Vectric, the program that we're using to create our cutting files with, get everything oriented, and we're pretty much ready to go. Now, along with all the individual triangular shapes, creating those cutting files, we also need to create the file in which we're going to cut the recesses in which they fit. We're going to create the negative space. As you can see here on the screen, this is the DXF file for that part that I had in Autodesk Inventor. And so what I'm going to do then is create a pocket cut of all those shapes. I'm going to use a straight bit because that gives a nice clean cut in plywood, and I'm cutting 1/8 of an inch deep. I'm choosing 1/8 simply because that's the minimum thickness that I can safely plane wood with my planer. So let's go ahead and get the CNC all set up, and let's start creating the pockets for our geometric design for our stained glass door. I'm all set up now to create the pocket cut in our door panel for our stained glass geometric pattern. I'm using Baltic birch plywood because it's got a fairly thick top veneer, and that way I can sand down a little bit when I go to level everything out. Plus it has that nice neutral color I mentioned earlier, which will really highlight many of our exotic species of wood. So I think we're all ready to go. Let me get some ear protection on and we'll press start. Well, there's the panel for our future door. You can see lots of places for putting nice exotic woods. So what's next? Well, I'm going to take this Palmera brush and I'm going to really scrub it down to get rid of some of the little fuzzies within these openings, make sure they're nice and clean. Then it's going to be time for us to set up and start cutting the 1/8 inch thick pieces that are going to fill these openings. Well, now it's time to cut all the little parts to fit into that panel. So I've got a piece of purple heart here, which I think ought to be really pretty. I'm very excited about it. Using an 1/8 inch bit straight, and that's going to give good clean sides to all my parts. They'll fit nicely. Now I will tell you one thing I have done is I went ahead and shrank my parts down to about 99% of original size, and it's just going to make them fit a little bit easier. Makes it a little easier on myself. I have tabs as part of the layout here to keep things interconnected. You might want to use some double-sided tape. I think the tabs are probably going to be okay. Now that we have all the parts cut for our door, the back, and all those exotic wood triangles, it's time to move on to the top and the bottom, the sides and the back of our cabinet. Now the back I'm going to take care of with the table saw because the back is just a piece of 1/4 inch plywood. The sides and the top and bottom I'm going to let the CNC handle. And I'm doing that because there's holes for the shelving pins, which need to be accurate, and I'm using dowels to hold the top, the bottom, and the sides together. You know, dowels are an underused form of joinery because, well, they're always a little bit tricky to get things perfectly lined up. But with our CNC machine, it's not a problem. The CNC is going to cut perfect holes in the top and the bottom, and I'm going to use it to create a simple jig which will allow me to drill mating holes in the ends of the sides. The machine's going to begin with drilling the holes for the dowels, then it's going to proceed to cut a slot for the back and the final profile cut. Well, the top and bottom are all wrapped up, so now it's time to move on to the sides. Now, one thing I didn't mention before is I did change bits after dealing with all that thin wood for our door. I now have an upcut 1/4 inch spiral bit. It's a great bit for solid wood like this. Running at about 1750 RPM at about 65 inches per minute. Seems to work pretty well. So we'll go ahead and get started here. The machine is going to begin by boring the holes for the shelf pins. It will then create the slot for the back and then cut the final profile out. Well, it's time to start putting all the pieces together into this puzzle. Now, the important thing here is to stay organized. What you don't want to do is start popping all these little triangles out of the boards, put them in a shoebox and shuffle them around a little bit, unless of course you like jigsaw puzzles. The way I'm approaching this is, I'm using the image that I created in Inventor, and I use those bright colors on there, of course, to delineate each type of wood that I wanted. So, as you see here, I've got a lot of orange parts. Well, those orange parts are Padauk. And so what I've done is I've gone ahead and written in each of those spots OR for orange, or it could just as easily have been P for Padauk. But that lets me know where each individual part goes. So what I do is I pop an individual piece out. I've got a little piece of sandpaper here, and it helps me grind the remnants of the tabs down. I find its mating spot, gonna make sure it's gonna go. And I want to use just a little bit of glue to make sure everything stays put. Doesn't need a whole lot, but a little bit. Press it in place, and I'm ready to move on to the next. So a little bit of patience, but it's a lot of fun. You know, to join a cabinet together, doweling is a pretty good choice, but I've never quite been comfortable with the fussy layout, trying to get an exact spacing, trying to get things exactly centered on the end of a board, making it all work out. It seems like every time I dowel something together, well, I end up having to trim one of the dowels a little bit with a knife to get it to force in. Well, with my CNC machine, doweling becomes a fantastic choice for a lot of joinery. One of the reasons I like it is that I can cut all my parts to the exact size without having to worry about adding extra for a tenon. And as far as it being fussy and difficult to lay out, well, hey, the CNC machine takes care of that for me. So here's a little cabinet I'm making, and this is the top. And you can see the machine has drilled 5 holes precisely located for the sides of my cabinet. The one thing the machine can't do is drill the holes in the end of my sides, but it can sure help out. What I've done here is just to make a simple CNC/shop-made doweling jig. The machine drilled 5 holes which perfectly match the spacing on my top here, and I simply glued a little piece of wood on as a reference so that I can clamp it to the outside face of my side. I simply line it up with the front edge of my side, clamp it in place. I've got a drill bit flag to the right depth, and I'm ready to go. That fast and that easy. And of course this is a one-time jig. I'm going to use it for this project and I'll be done with it. But I've got a lot of versatility because I can make this any size and for any application to make sure I'm referencing accurately and giving me great results. So doweling, it's a great choice with a CNC machine. Well, I think we're all ready to start gluing up the cabinet. So I've got my top, my bottom, my sides, my back, and a bunch of dowel pins. So I'm going to go ahead and start by getting glue in my holes and on some dowels and getting them inserted into this bottom. Okay, our cabinet is together. Last thing I'm going to do is to check it and make sure that it's square, give it a final look over to make sure I've got all the glue off of it, and then stand back and let it dry. Well, I've got my cabinet all assembled, so let me point out a couple of details. First, let's take a look at the door. One thing I've done is to add some edging around the exterior after I got it cut and fit to the correct size. Now, I've never liked wrapping wood all the way around the outside of a door where you can see the glue line on the face. So instead, I just created a rabbet and I went up to about the second layer of veneer on this plywood, cut some 1/16 inch maple and glued it in place. Makes for a nice clean look on the front, nice clean look on the edge. To mount the door, I've used European hinges, and I really like them because there's so much adjustability. Another detail is that I routed a small cove into the side here as a finger hold for the door. Now I know normally we put those sorts of details in the door itself, but because of the thin edging, that wasn't going to work. The sides are solid wood, and so that's the place to put the finger hold. You'll also notice we've got two shelves held in place with standard shelf pins. To finish this cabinet, I'm going to use about 4 to 5 coats of a nitrocellulose lacquer, and I'm going to use lacquer because it doesn't impart color to the wood. An oil-based varnish is going to yellow things out a little bit, and I want to keep things very bright, very clean looking. An alternative to nitrocellulose lacquer would be any of the water-based finishes that are currently available. They really do a great job and they're very friendly for the home shop. Well, I hope you've enjoyed this month's project, and I hope you're thinking about ways where you can use geometric designs in picture frames, jewelry boxes, cabinets, and all sorts of different applications. All the DXF files will be available to you to create this project, and if you build it, be sure to send us a picture. Another really fun way to create interesting geometric patterns is instead of cutting out shapes and applying them like we're doing for the stained glass door, is to use a reductive method. In this case, what I've done here is that I've cut through the surface of some cherry veneered plywood and I'm exposing the MDF core underneath, which has a nice consistent color to it. The process is essentially the same as we did with the stained glass door. I went to the internet, I explored different patterns, I found one that I liked, I traced over it, and then I made good use of the array tool in my drawing program. So I went from one pattern to creating rows and columns. And you can get very busy in a hurry with that. It's easy to do. Now it will challenge the RAM on your computer a little bit, so you might have to kind of slow things down and be patient when you have this many different objects. The bit that I'm using to cut this is a 1/8 inch straight bit. Now that does produce slightly rounded corners in the pattern. If I had want to tighten that up a little bit, what I can do is use the 1/8 inch bit to remove the bulk of the material and then go back with a 1/16 inch bit that traces the outer profile. And that'll really give you a good, sharp, crisp looking detail. Now I think this looks pretty good with the lacquer on that cherry, but if you'd like to add a little color, it's an easy thing to do. So this is the same panel, but I've added some Sunglow yellow to the recesses. What I did was just took my brush and basically stippled it in there, being very careful to make sure that all the area was covered. I then took a rubber float like you'd use for grouting tile and squeegeed off any of the excess paint. I let it dry overnight, then I came back and using my orbital sander, I resanded the surface. That surface had previously been sealed with lacquer so the yellow paint didn't penetrate. Once I'd resanded, I then re-lacquered, and that makes everything bright and clean again. Now I used yellow, but think about how striking something like a turquoise blue would be against that reddish cherry. There's all sorts of wonderful combinations that you can do. And you could also use different colors depending on the complexity of your design and depending on your patience. So it's a great alternative. So it's reductive routing And it's using patterns and it's using the array tool in your design programs. I'm always amazed at all the different options and features of the software that we use. I've got a copy of Vectric VCarve Pro up here, and there are so many different tools and different things in that I really can't keep track of them all. An example of this is the other day I was bringing in all these small parts that you see here on the screen, and I was trying to position them on my workpiece. And so I was grabbing each one, bringing it up, rotating it as needed, and carefully trying to place them all into a 6 by 24 inch piece of wood that we're going to use for our stained glass door for today's project. Slow and laborious, I'll tell you that. Well, our producer, Becky Kralachek, comes over to me and she starts telling me, well, she's got a Cricut at home and she can just grab all these different parts and it automatically places them. And I remembered, oh yeah, Vectric has that same feature. So it's pretty easy to use. So let me highlight the parts. It's got a couple of different settings for tool diameters, border gaps, and things like that. I'm going to preview it. Boom, there they are, all neatly nested on my part. And I can press OK, and there we go. So in about 2 seconds, they're neatly nested, whereas I was spending about 5 minutes being pretty unhappy trying to put them there. So it's always fun to discover or rediscover a great feature, a great tool with any of our software. So if you have something that you've discovered that really works well for you, hey, write us. I'd like to share it with all of us. If it has to do with software, hardware, whatever it is, if you've got a great tip, please send it along to the rest of us. We'll be sure to get it on in the next episode. So we'll see you next month on CNC Basecamp. This episode is sponsored by Inventables. Design it, build it, sell it. Learn more at inventables.com.